So I have discussed in some previous sessions how to derive the equation of continuity, the Bernoulli's equation, which is nothing but conservation of energy. Okay. So equation of continuity is nothing but conservation of mass. Okay. So without going into the details of the derivation of Bernoulli equation, I will just write down the equation. Then with the help of that equation, we can explain many practical real world example like the reason behind that particular thing, why it is happening. So that can be explained with the help of Bernoulli's principle. Okay. So we told that Bernoulli's equation is nothing but conservation of energy. Okay. So in fluid flow. Okay. So basically, suppose if you have a pipe. Okay. So you have a pipe. So you have fluid flowing. Okay. You have fluid coming and fluid entering and fluid going out. Let us say this is my point one and this is my point two. Okay. So if this is the case, uh, whatever is the like say, let us say it will have some with reference to some reference plane. Let us say this is at a height h1 and this is at a height h2, right? Okay. So there are three energies that the fluid is having. Okay. So those three energies are like your pressure energy, velocity energy, and the potential energy or the datum energy. Okay. So that equation we can write it as like say pressure energy. You can write pressure energy as P1. Okay, that's the pressure. And also you know that pressure is equal to rho gh. Rho gh means the height of, like say, we say atmospheric pressure is 760 mm of Hg. So it is nothing but 760, that is the H, then rho and G. Okay. Rho of mercury is 13.6 times higher than that of water. So water is 1000 kg per meter cube. Mercury density will be 13.6 into 1000 kg per meter cube. Then G is nothing but your acceleration due to gravity. So likewise we calculate pressure, which is nothing but your rho gh. The final SI unit you will end up will be Pascal, which is nothing but Newton per meter square. Okay. So here unit is very important. When you are adding different things, everything should have same unit. So if this is pressure, other two terms like the velocity head should have also same unit. Like that should also be in unit of pressure or Pascal. Okay. Yeah. So I am not deriving it. That is just plus half rho V1 square. Just remember this, and then the third term is your potential energy or the datum head. Okay. So that is rho G. Sorry, this is rho GH1. Okay. So this is at point 1. H1. Okay. So this is equal to P2 plus half rho V2 square plus rho GH2. Okay. So this is called your pressure energy. Pressure energy, or pressure head also you can say. Pressure head. Okay. No, pressure energy you can say. When you convert it into head, like if everything you divide by rho g, then it will become head. Okay. So this is pressure energy. This is your velocity energy. And this is your potential energy. Okay. So these are the three energies. So total energy consists of pressure energy, velocity energy, and your potential energy. So if you add these three things at this point, it will remain constant. So this is conservation of energy. Yeah. And you had equation of continuity, which is A1 V1 is equal to A2 V2. So this is nothing but volume flow rate. Okay, A1 V1 is volume flow rate. Because we are considering a incompressible fluid here, the density remains constant. So actually it is rho A1 V1, rho A2 V2. So that is nothing but your M1 is equal to M2. That means mass cannot be created nor it can be destroyed. So that is this
Conservation.
is conservation of energy, Bernoulli's principle. Conservation of energy, whereas this is conservation of mass. Your equation of continuity, okay, of mass. So this equation has this, with the help of this equation you can justify many real world events that are happening, okay. So one such thing is your in aerospace engineering, this Bernoulli, with the help of Bernoulli's equation many things can be solved, okay. So you know, uh, in case of an aircraft, okay. So so let us say this is my aircraft, okay. So I have a wing here, okay. So let us say the wing looks like this is a wing and I will have a tail plane here, okay. So I will have a tail plane, I am just taking a section here, okay. So when the aircraft like in the year 1903, the Wright brothers invented this, proved the first flight happened in the year 1903, Wright brothers, okay. So the like from many years humans have always tried how to fly like a bird, okay. So they have tried to see actually how does a bird fly, okay. So with a lot of experimentations, lot of research, they have they have created a like that Wright brother have were successful in creating a like say powered flight, okay. So earlier there used to be like this unpowered flight, okay. So like without having an engine or anything, they have tried to replicate like this parachute and gliding and all those things you might have seen. Like in some cases you can have unpowered flight also, okay.
Yeah.
So in 1903 there was a powered flight, okay. Okay, so not going into details of it, in a aircraft, when a aircraft is moving in a, like say, suppose you are moving going from Bangalore to Bhubaneswar, okay. So that is the aircraft may be traveling at a height of say 11 kilometer or so, okay. So when it is moving at a height of 11 kilometer, it is kind of a level flight, okay. So it will be like this. The mission of a aircraft will be like this. First, it will move some distance, attain the velocity. Then it will go up. Okay. Then it will maintain a particular height, and then again it will come down. Okay. Right, like this. Okay. First, the initial one, it is like rolling of the aircraft, and then here the takeoff starts. After, then it will maintain some height, okay. So let us say 11 kilometer or whatever, okay, and then it will be moving at some speed. Let us say some 800 kilometer per hour, okay, 800 kilometer per hour, okay. So this is nothing but these are subsonic aircraft, okay. Sonic speed, if we convert the velocity of sound in kilometer per hour, it will be coming something around 1120 kilometer per hour, okay. So this aircraft moving at an altitude of 11 kilometer, flying at 800 kilometer per hour. So this is takeoff. So this is takeoff, and this is your landing. Okay. So actually, what are the forces acting on an aircraft? See, something is at such a high altitude. Something is the aircraft is flying. Okay, so it will have its own weight. Okay, so there are some 200 passengers sitting in that. Okay, so let us say each passenger is of let us say 100 kg. Okay, so 200 into 100 kg. Okay, yeah. So it will become 2000 into 200 into 100 is nothing but 2000. So 20 ton. 20. So 20 ton is the passenger weight. Okay, so there is a thumb rule. The aircraft structure will have some weight, that is also 20 ton, okay. The structure like the fuselage, wing and all, So that is also 20 ton. Similarly, you are carrying some fuel in the aircraft also. That will also be 20 ton. So one third, one third, one third. The passenger weight is one third. That is called the payload, and the fuel weight is one third. That is called the fuel that is for the operating the aircraft. And then you will have the structure, which is so some 60 ton. Okay, so 60 ton is a very big weight, like 60,000 kg. So such a big weight, so mass into g. So that much of downward force is already acting on it. Okay.
Downward.
So let us say you have the CG here. Okay.
Oh.
So you have the CG. So there is a force W. Let us say of 60 ton, which is nothing but 60 into 1000 kg into 9.8. So this many Newton of load is acting on it.
Downward.
So this has to be balanced, otherwise it will fall down.
Yeah.
Okay, so this is balanced by some force that is called a lift. Okay, that is a lift. So that lift is generated by pressure difference between the upper and lower surface of the wing.
Okay.
So who generates the lift? The wing generates the lift. Okay. So I will explain you how it is happening. So if you take only the wing cross section, okay. So let me say this is my wing. Okay. So this wing actually I have done it reverse. It is not like this actually. The lead one is called the leading edge and another is called the trailing edge. Okay. So it is something like this. So you will have the wing as like this. Okay. So this is your wing. It will look like this. So this is your leading edge, and this is will be your trailing edge. Okay, right? So so the air is flowing like this. Okay, the air is flowing. So actually it is moving down like this. So it will meet the air. So it will just caught the air, right? It will caught the air. Okay. So when it caught the air, I'll just explain it in detail later. So there, the aerofoil surface behave in such a way that there is low pressure on the upper surface, there is high pressure on the lower surface. So pressure means what? Pressure into area is nothing but your force. So there is a lesser force acting on the upper surface, there is a higher force acting on the lower surface. So if you are there is a unbalance between the upper and lower
Pressure
force,
difference is there.
it will try to lift it up. Okay. So
Understood.
yeah, so it will try to lift it up. Okay. It is something like this. So it will try to lift it up. The air, it is facing the air, and it will try to. There will be a pressure difference. Let us say this is 0.1. Let us say this is 0.2. So what will happen? Your P1 will become less than P2.
P2.
So there is a differential force between upper and lower surface, and it will try to lift
Yeah.
it up. Okay. So the bird's wings are also operating on the same principle. Okay. Their cross section is also called airfoil cross section. Okay. Airfoil cross section. Okay. So because of the pressure difference or the imbalance force, there is a lift. So this lift is balancing your weight. Okay. So because they are balancing each other, the aircraft is not falling
coming
down. Okay. And also when the aircraft is flowing, actually this is ulta. Okay. So this is kind of ulta. Okay. So let us say this is ulta like this. This is the cross section. So aerofoil cross section. So lift and weight you understood. So and your aircraft is moving forward, right? When it is moving forward, like there is a viscosity we have studied, right? Viscosity is nothing but the friction. Okay, so in fluid flow, this viscosity causes friction. Okay, so there will be a frictional force, right? That is called the drag. Okay, so when the faster you move through the air, the more is the drag. Okay, so that drag force has a formula that is like half CD rho A V square, right? Rho V square. This is CD is called your drag coefficient, like your coefficient of friction and all that. So there will be a force. I told half rho A V square is nothing but pressure, right? Pressure into A area is your force. CD is a non-dimensional number. So that much of frictional force will be acting on an aircraft. So when you have a frictional force, it will be opposing the motion of the aircraft, right? So my aircraft is moving like this. So I have a frictional force which is acting on the aircraft, right?
Yeah.
So I have a frictional force acting on the aircraft. So to overcome that friction, I need to have the engine, right? So I have an engine in this aircraft, okay? So these engines will be sitting on the wings actually, okay? So if I see the aircraft from the front, so it will be a circular thing like this, and this is my wing, and my engines will be sitting here, okay? So these are my wings. So this is my engine sitting on the wings. So when the aircraft is moving, the air will enter in the engine.
Yeah.
So the air will enter at a particular velocity, but it will be exiting at a much higher velocity. So the air will get accelerated by doing some combustion inside and all that, like a nozzle. Okay. So the engine is something like this. So this is kind of my engine. So my air is entering at a velocity v1. My air will go out at a velocity v2. So this v2 is always greater than v1. And let us say my air fuel mass that is entering, mass flow rate is say, let us say m dot. Okay, so I will have a engine force. Okay, that force is equal to, that is called the thrust. Okay, the thrust produced by the engine is equal to m dot into v2 minus v1. Okay, so this is the momentum, rate of change of momentum is equal to force. That is Newton's second law. So this thrust is acting here, and this is the drag. So this thrust is equal to the drag force. So otherwise I can write it as drag D. Okay. So this is my drag force. Okay. So this thrust and drag are balancing each other, and your lift and weight are balancing each other. Okay. So that's how the aircraft. That's the basic four forces acting on a aircraft. Okay. So yeah. So if you see, if you draw like what are the four forces acting on an aircraft? So this is your thrust is acting forward, this is your drag acting backward, and this is your lift acting up, and this is your weight acting down. So thrust is equal to drag, lift is equal to weight. These are the four forces, right? So this is, so when all the forces are in equilibrium, it will be moving at a constant velocity. It is moving at 800 km per hour. That's the constant velocity. It is not accelerating. Okay. So if there is a net force, like see, if the engine force is more than that of the drag, then it will accelerate. Right. Sometimes in aircraft at the landing time or in the takeoff time, in landing it will decelerate. During takeoff it will accelerate. Okay. What happens? It will start from 0 speed, and it will reach something around 200 km per hour. Okay. When it reaches 200 km per hour, there will be a pressure difference created between the upper surface and lower surface. After reaching that 200 km per hour, it will lift up.
Yes,
so that is the difference between a helicopter and aircraft. Okay. For a aircraft, you need to run on some for some distance. Let us say for 2 km, if it runs for 2 km, then only it will achieve this speed. See, you have a formula called v square is equal to u square plus 2as, right? Yeah. This s is the distance. So in this case, that s is your runway distance. Okay, that s is your runway distance. So if it moves on the ground, after it moves for around 2 km, then only it will achieve that velocity. Because my u can be 0, okay, but my velocity will depend on my distance covered. Okay, so after reaching that particular velocity, after traveling 2 km, then only the lift will get generated. That's why For aircraft, you need a long runway. Like say you might have seen in Bhubaneswar, we have while landing or while taking off, you need some 2 kilometer distance. Then only it will lift up. But in helicopter, we don't need any runway. Okay, so it will create lift by there will be a rotor sitting on the helicopter. So by adjusting the angle of that rotor blade, so in a helicopter you will have kind of some kind of you will kind of have some rotor. So that rotor blades it will be adjusted in such a way that it will create lift on its own. Okay, so that's why it is called helicopter is called vertical takeoff or landing. Okay, on its own it will take off, on its own it can land. So you don't need, so like a helicopter can land on the rooftop also, and it can take off from the rooftop also. You don't need any distance. So that's why the helicopter can land on any, like say these defense to reach unreachable areas. You need helicopters. They are this like say Siachen and all. Okay, high altitude area, all that. So there you need helicopters. So when I was working in HL, we have aircrafts and we have helicopters also. So all these defense forces they need aircraft, they need helicopters also. So for difficult areas where aircraft cannot land and all, there you have to use the helicopters. Okay. So yeah, so this is you understood what is Bernoulli's equation and how uh, uh, this is being applied for in aerospace applications. Okay, so here you can see if you forget this H1 H2, you can see that when if velocity is high, the pressure is less. So here what is happening at the top, the velocity is high, the velocity is becoming more. At the bottom, the velocity is less. That's why at the top velocity is high. That's why pressure is less. At the bottom, velocity is less. That's why pressure is high. So based on Bernoulli principle only, there is a pressure difference. P1 is less. P1, P2, there is a difference. That's why the lift is getting created.
Down it is more.
Down the pressure is more. Pressure is more means force is more.
That so is why it gets dragged.
It will lift up. Okay. So we'll try to solve one numerical on it. Okay. So take a picture of this. You have taken. Oh. Okay. So the main thing is P1 plus half rho V1 square plus rho GH1, right, is equal to P2 plus half rho V2 square plus rho GH2. Okay. So you just forget that they are at same height, forget. So this will get simplified to P1 plus half rho V1 square is equal to P2 plus half rho V2 square. So this is the governing equation. So now with the help of this equation, we will try to solve one numerical. Okay. So this is Boeing Boeing aircraft problem. Okay. So we have two major aircraft manufacturing company in the world. They are called Boeing and Airbus. Okay. So almost 50-50. So whatever you aircrafts, civil aircraft, transport aircrafts you see in the world, mostly 50-50, not exactly 50-50, 40-40 will be Boeing and Airbus aircraft. Okay. So we will solve one Boeing aircraft problem here. Okay. So the question is like this. A fully loaded Boeing aircraft has a mass of 3.3 into 10 to the power 5 kg. Okay. So the mass of the aircraft. Okay. So now let me draw this aircraft. Okay. So I think this name is not writing. Okay, so